Because a half plus 9 halves is 10 halves. 10 halves is otherwise known as 5. So that's 5 e to the 3t. And then you got a half minus 9 halves, otherwise known as 8 halves, minus 8 halves, otherwise known as minus 4. Yep, yep. So if for some reason you find this form of partial fractioning like a pain, and it just really offends you to do it, you could like become masters of Cauchy-Cinch and do this. These formulas are true, what I wrote down, for essentially the same reasons as I did earlier today with sine and cosine. You could do an analogous calculation over the hyperbolic numbers and be the same calculation. Now I'm just talking to you, Luke. Let's see here. I'm sorry, guys. Yep.
I'm really not sure about some of the steps you did in that very first one.
Yes.
Yeah,
I know, right?
I like wrote it down, but
Yeah, no. So you got to think about what I did and why I did what I did. It's all about the table. It's all about the end game. You know how to inverse transform exponential times sine, exponential times cosine. What are the patterns you're looking for? You're looking for something of the form s minus alpha over s minus alpha squared plus beta squared. And you're also looking for beta over s minus alpha squared plus beta squared. That inverse transforms to sine beta t times e to the alpha t. This inverse transforms to e to the alpha t times cosine beta t. So you got to keep in mind keep in mind what you're doing. Trying to calculate the inverse Laplace transform, you have to find a lifeline, and you have to find a bridge across the abyss, right, or whatever you want to think of it as. And that's your list of things that you can do right here in this table 7.1, right? So b over s minus a squared plus b squared. So I have beta instead of b, and I've got a alpha instead of a. But you see, when I get to that expression, I can go back to exponential sine or exponential cosine. That's why I did what I did, because once I complete logically, here's what's going on. First of all, I complete the square. That tells me what kind of problem I'm dealing with. Here, completing the square, sum of squares, it's irreducible. That means it's going to go to sines or cosines times exponentials. In contrast over here, I could factor. If I had completed this square, it would have looked like that, which would have been a dead giveaway this factors. So either you can embrace the Cauchy-Cinch way of being and do this. I don't recommend it unless you really understand it. Or this is the standard way of doing it. You go, well, factors, so I look for a partial fractions decomposition. And because the reason I do that is because once I get to 1 over s minus a, it's on the table. Right, 1 over s minus a, number 2, the Laplace transform of e to the at is 1 over s minus a. So when I see 1 over s minus a, I know how to inverse Laplace transform to get back to e to the at. Right, inverse Laplace transform of s 1 over s minus 1, e to the t, inverse Laplace transform of s minus 3, e to the 3t, right? Now over here, I can't do that because it's irreducible. So I got to look for the sines and cosines. So once I complete the square downstairs, it tells me I'm looking to put an s plus 2 upstairs. So my coefficient here is s. Now, here, different problem. If I had 7 here, then what I would have done is I would have put a 7 here, and I would put a parentheses. That would have added 14. Being that I only have 3 here, and I added 14 by doing that, I would have had to put 11 here. Again, I'm forced to look for s plus 2 over s plus 2 squared plus 6, or the square root of 6 over s plus 2 squared plus 6, because 6 is, I haven't written this, but I'm assuming you guys realized I was thinking that. So that forces the beta to be 6. I got to create a beta here in order to use the inverse transform. There's a beta in the numerator. It's got to come from somewhere, so make it appear. To quote a venerable captain, make it so. Yes?
in your initial case, shouldn't you just have 1 over root 6 instead of 3 over root 6 to balance? Because you added, or you subtracted 1.
Oh, yes. You guys are right. Dang it. Thank you. Yes. Yeah. No. No, I'm not making up new math. I'm just. I do make mistakes sometimes. Yes, you're right. That should have been a 1. Thank you. Which would have made this a 1 in the original problem, right?
It was that step that I wasn't getting.
You gotta.
I was thinking why you're.
Okay. You should just interrupt me. When you have that feeling, interrupt me.
Okay.
I'm probably wrong. Women, what can I tell you? Sorry, it's a fall of man comment. For those of you not.
We'll edit that one out.
We'll edit that one out. Hey, that comment will be presidential before long, so, where was I? Yeah, that should have been, so if that's 3, this stays that just becomes 1, and then, yeah. Right. So if I, of course, if I put a 7 there, then that's going to change that to 11, and it'll put a 7 here and an 11 here. So, yeah.
Wouldn't there also be a minus sign since it was 7 times s plus 2 that you had up there originally before you erased it?
Oh, right. Yeah, good point. So plus 14, so I have to subtract, yeah, right. I have to subtract 11, very good, yeah. So these things you have to be careful. But I hope I'm at least communicating to you the big idea of the calculation, right? I mean, some people will teach students that you do a partial fractions decomposition here. Like once you get to something like this, right? Then you say that this is equal to like a times s plus 3 plus b times the square root of 6 or something like that over s plus 2 squared plus 6, and then they'll do algebra to work it out. And yeah, you can do it that way if you want, but trust me when I tell you that this way I'm showing you of creating the s plus 3, right, by factoring out the appropriate number and adding or subtracting, doing arithmetic, and then creating up here by division. That's just way faster than working out this algebra. If you take the time to get used to this arithmetic, it's much faster than actually working out the a and the b like that, where there's a lot more writing and really a lot more opportunities for making mistakes as well. I don't think I've made a very convincing case, though, given my own shortcomings. But anyway, I'm not taking the test, so. Sorry. Anyway. Hey, I am teaching this class next semester, so, whatever happens. We got room. I'm only I think I've still got seats. I mean, I hope you guys make it. I think you're gonna make it. I'm just kidding. Do make sure you keep these sheets, though.
Gotcha.
Yep.
Did you take this tomorrow?
The homework, I suppose I could take it tomorrow if it's very helpful. Sure. I can give you guys another day. Why not? Yeah.
Thursday in class.
Yeah, Thursday in class, because if I let it go to Friday, then people will be like, I had to go on break and I forgot to turn it in. I just don't want to hear it. Wait a minute. Break starts after this Friday, right?
Yeah.
That's amazing. Or terrifying, I'm not sure which. It's amazing? Okay, let's stick with amazing. Thanks, guys.